All right, let's talk about Cisco's SD access. We're going to break down how this technology completely flips the script on the traditional campus network. Okay, so here's what we've got on tap. We'll kick things off with the big idea, then build our way up from the physical layer to all the cool virtual services on top. Then we're going to peek under the hood at the tech that makes it all tick, and finally, wrap up with why this whole thing really matters.
All right, first things first, we've got to wrap our heads around the big idea behind a fabric network. Because really, it's a huge shift from how we've always done things.
So what is a fabric network, really? At its core, it's basically a smart, logical network that you build right on top of your physical hardware. This creates two totally separate layers, and that separation, well, that's the secret sauce for everything we're about to get into. And this image just nails the whole concept. You've got the underlay. Think of this as the physical network, the actual switches and routers. This is your raw transport. And then sitting on top, you have the overlay. That's where all the smarts, all the services actually live. I love the analogy of physical roads versus bus routes. The roads just provide the path, right? But the bus routes are the intelligent service that decides who goes where and when. Okay, so let's get into how this is actually built. We're going to start from the ground up with the foundation, the underlay network. This is all about the physical stuff. So the underlay's job, it's pretty straightforward, but it is absolutely critical. Its one and only goal is to provide solid, scalable IP connectivity between all the devices in the fabric. It uses a standard routing protocol, like ISIS or OSPF, just to make sure every fabric node can talk to every other fabric node. The key thing to remember here is that the underlay knows nothing about your end users, your devices, or their subnets. It's just a dumb, fast, stable highway system. All right, so we've got our highway system. Now it's time to build the smart stuff on top of it. Let's talk about the overlay. This is where the magic really happens. All the intelligence and the advanced features, this is where they live. So check this out. Your end user devices, your laptops, your phones, they connect directly into this virtual overlay. The overlay then does something really clever. It takes their traffic, wraps it up in a little package, and sends it across that physical underlay to get to where it's going. The user and their device, they have no clue the underlay even exists. It's totally transparent. And because the overlay is totally separate from the physical network, it unlocks some incredibly powerful capabilities. I'm talking about things like users being able to walk anywhere in the building, even across campus, and keeping the exact same IP address. It's seamless. We can also slice and dice the network for security, creating super fine-grained segmentation. And we get to manage all our wired and wireless users under one single unified policy. Honestly, trying to do this stuff in a traditional network, it's a nightmare. Here, it's just built in. So you're probably wondering, how does this all actually work? It's not magic, right? Well, the overlay's functions are neatly divided across 3 different but very cooperative operational planes. Now, this slide is fantastic because it really breaks down the division of labor here. You've got the control plane, which uses a protocol called Lisp. Its whole job is to answer the question, where are you? Think of it as the GPS for the network. Then you have the data plane, which uses VXLAN. Its job is to figure out, how do I get there? It's the actual transport vehicle that packages up the data and moves it. And finally, the policy plane, running Cisco TrustSec, acts like a security guard. It asks the most important question, are you allowed to go there? Okay, let's zoom in on the control plane, which is powered by Lisp. And Lisp is a real game changer because it fundamentally rethinks how we use network addresses. It does this by creating a clean separation between who you are and where you are. And this separation is the crucial concept. You have the endpoint identifier, the EID. That's the who. It's your device's permanent identity, its IP or its MAC address. Then you have the routing locator, or RLOC. That's the where. It's the IP address of the switch your device is currently plugged into. So what happens when you move? Your EID, your identity, stays exactly the same, but your RLOC, your location, gets updated. That's the secret behind seamless mobility. And it's super important to know that the version of Lisp used in SD Access isn't just your standard run-of-the-mill Lisp. It's been seriously beefed up. It adds critical support for Layer 2 virtual networks, not just Layer 3. It makes fast roaming possible for things like voice calls. We're talking under 50 milliseconds. And it fully seamlessly integrates the entire wireless network. Okay, moving on to the data plane. For this, the fabric uses the technology called VXLAN, and its job is to package up all the traffic for its trip across the underlay. The best analogy is putting a letter into a standardized FedEx box before you ship it. VXLAN is that box. And this diagram shows exactly how that works.
See, it takes the original packet from the user and it wraps it. It encapsulates it in a whole new set of headers. And that green VXLAN header you see there, that's the key. It contains the virtual network ID, the VNID, which handles the segmentation. But it also carries the scalable group tag, or SGT, which is all about security policy. So this one header does double duty for both Layer 2 and Layer 3 overlays and carries security info. Pretty efficient. And that brings us to the final piece of the puzzle, the policy plane. This uses Cisco TrustSec and those SGTs we just mentioned. Now this is cool. It lets you create security rules based on roles. Think employee, guest, or IoT device, instead of having to manage these huge, complicated, and fragile IP-based access lists. Your security policy is now tied to a user's identity, not where they are or what IP address they happen to have today. All right, let's pull this all together. We've gone through the architecture, we've looked at the key technologies. So what does this all mean for you? What are the real, tangible benefits of building your network this way?
Well, the advantages are pretty massive. First, you get segmentation on 2 levels. Macro segmentation to isolate traffic between big virtual networks, and micro segmentation within those networks using the tags. You get true, seamless mobility for literally any user or any device. Your core network also gets a lot simpler and more efficient because it doesn't need to know about every single endpoint, just the locations of the switches. And maybe the biggest one of all, the entire intelligent overlay is fully automated by a controller like Cisco DNA Center. It just abstracts away all that underlying complexity for you. You know, when you sit back, this architecture is a fundamental shift away from the old box-by-box command line way of managing networks. It moves us to a system that's driven by policy and powered by automation. And it really leaves us with a big question to think about. As our networks get more and more complex, and the demands on them get more dynamic every day, is this kind of separation, pulling the services apart from the transport, is this the only way we can actually manage things